Hello, this is Mr. Stansbury. I'm going to take you through the notes on areas of rectangles and parallelograms. At the end of this, you should be able to say, I can solve problems using the areas of rectangles, parallelograms, and composite figures. And I can use coordinates to compute perimeters and areas of figures. All right, so first thing, area of a rectangle. Area of a rectangle, hopefully you remember from before, is length times width. So this one here is going to simply be 7 times 15, which is 105 square meters, right? Because area is always whatever the units are squared. Okay. Area of a parallelogram is also length times height. So this is the length and this is the height. This is not the height, but sometimes you'll need this number to figure out what the height is. But in this case here, the length is 10 and the height is 6. So 10 times 6 is 60 square inches. All right. Find the area and perimeter of the following shapes. So now this one's a weird one because it's basically like a rectangle, but it's missing another rectangle. So you can do this a couple of different ways. You could find the area of this big rectangle here and then subtract the area of the small rectangle on the middle. Or I think an easier way to do that is to actually just cut this thing into two smaller rectangles and find the area of each rectangle. Okay, so we know that this length here is 2. We got to figure out what this length is here. So this length is 3, and this length right here, since this is a rectangle, this is going to be also a 2. So this whole length right here, 3 plus 2, this is going to be 5. So the area of this is 2 times 5, which is 10. And then that's the symbol for feet, so that's 10 square feet. And then this is 2. This whole thing is 6, but we know that this part right here is 2. So if we take 6 minus 2, that means that this over here is a 4. So to find the area of this would be 2 times 4, which is 8 square feet. So then we would take 10 square feet plus 8 square feet to give us 18 square feet for our answer for this one over here. Okay, this one over here, we've got, this is our parallelogram. So we have to know the base. So these are parallel sides here. These are parallel. So this is a parallelogram. So this is 14 down here as well. And then what we need to know is we need to know this height, but we don't know that height. So we got to figure out what that height is going to be. Okay, so this is 7 here. So this is going to have to be 7 here. All right, now, in order to figure out what this height right here is, here's the nice part. This is a 45-degree angle, so that means that, and this is a 90, so that means this is a 45-degree angle. So that means that these two sides here, this height and this piece right here, are the same. So we have this here is a length of 7, so we got to figure out what these two are. So if you'll remember, this is a 45, 45, 90 triangle, and this is 1, 1, root 2. So basically you could do this, or we can just, you know what, let's not even use this. Let's just, because you probably aren't going to remember that long term, but you will always remember a squared plus b squared equals c squared, or at least I hope you will. So we know in this case here the c is 7, but since these two sides have to be the same, let's call this a. So then this side over here is going to, we can call that b, but it's also going to be the same length as a, so let's call that a also. So it's really going to be a squared plus a squared equals 7 squared. So a squared plus a squared is 2a squareds equals 7 squared, which is 49. So we want to solve for a here, so we got to divide both sides by 2 first. And that'll give us a squared equals 24 and a half. So then we square root both sides, and that will tell us what this height is here. Okay, so pull up our calculator here, and we're going to take the square root of 24.5. Oops, I missed that. So square root 24.5. There we go. 4.947. So let's call it 4.95. Okay. So this height here is 4.95. So to find the area of this whole thing is going to be 4.95. That's the height times the base, which is 14. Okay, so here's our non-rounded number. So let's just do this, 4.9497. So take that and multiply it by our height, which was, or sorry, our base, which was 14. And that'll give us our area 69.3. Okay, equals 69.3 yards squared is going to be the area of that there. Okay, got one more example, but before we do that, let's take a quick little comedy break. Okay, here's our quick little comedy break.
I don't know who's writing books for babies, but I want a piece of that financial pie. I put my daughter on my lap with this big cardboard book, The Clock. The big clock. Tick-tock. The end. $12. And there's a synopsis on the back that is longer than the actual book, and I'm not exaggerating. Sit down with your children and you will delight as you read about the adventures of the ticking clock. Sometimes it goes tick and sometimes it goes talk, which just goes to show you you never can be too sure in life, because sometimes things are one way, but they are about to change. Are you talking about this book?
Okay. Last one here. Graph and find the perimeter and area of the figure with the endpoints, so forth and so on. So let's go through and graph this thing here. All right, so we've got -3 and 4 is A. 2 and 2 is B. 2 and -4 is C. And then D is -3, -2. And there's D. Okay, so now we've got this lovely looking figure, and we're going to find the perimeter and the area of this thing. Okay, so here we go. Perimeter. Well, we know these lengths right here. That's 1, 2, 3, 4, 5, 6. So these are 6s here and here. And we got to figure out what this length is right here. So probably the easiest way to do that, you can do the distance formula, or we can just simply make this into a square. I mean, sorry, a right triangle. So let's do that. Right, here is a right triangle with this side length here of 2, and this is 1, 2, 3, 4, 5, and this is a 5 right here. So to figure out what AB is going to equal to, well, AB squared is going to equal 2 squared plus 5 squared, right? Because this AB is the radius. So AB squared is going to be 4 plus 25. AB squared is 29. So we square root both of those to get that AB is whatever the square root of 29 is here. Second square root 29, and we get the square root of 29. Not helpful, but the decimal 5.385. So let's call it 5.4. Okay, so this length right here is 5. We're going to call that 5.4. And then again, these are 6s here. And then this is going to be a 5.4. So the perimeter is going to equal 2 5.4s and 2 6s. So it's going to be 2 times what? 11.4. So that's going to equal what? 22.8. It doesn't give us the units here, so we'll call it units squared. Oh, not squared, but just units is our perimeter. Okay. Now, area is going to be the base times the height. So we can either think of this as the base and there's the height, or this is the base and there's the height. I'm going to highly suggest finding this being the base and this being the height. So let's do that in green. So the area is going to equal base is 6, and then the height is, and we can just simply count this, and we already did it right here. This height here is 5, so 6 times 5. Area equals 30 units squared. Okay, and then there's our perimeter over here. All right. Okay, that's all there is for areas of rectangles and parallelograms. If you have any questions, please feel free to ask. Thanks.